Welcome back to part 2 of Solve Rate Problems. This time we're going to use number lines and equivalent ratios to solve rate problems. A veterinarian measures the number of heartbeats her dog and cat for 4 minutes and recorded the results on the table. At these rates, how many more times does the cat's heart beat in 6 minutes than the dog's heartbeat? And we're going to look at 2 different ways of solving this. The first one is going to be method 1, using the number line that we've done before, the double number line. So we're going to scroll down and take a look at how that one worked. Now this should be a straight up review to you, but let's go ahead and look at it anyhow. You can see that they've created a double number line here, and on one line they have heartbeats, on the other line they have minutes, with the goal being to get to 6 minutes here. They know that you've got 160 beats in 4 minutes as a difference between the cat and the dog, and we found that right here. They subtracted 360 from 520, and that is where they got this 160 beats to go in at the 4-minute time period. Now you have to take and move through your double number line in order to fill out the rest of the information. So, moving to the next slide, we can see that if we were to take and divide 160 by 4, that means 1 minute would be 40 beats. Continue filling out the line from there, and as you do, you'd have 80, 120, 200, and the final goal at 6 minutes would be 240 more beats for the cat than for the dog. Method 2 requires the use of equivalent rates. This is another concept that we've worked with before, and we're going to go ahead and take a screenshot of how we do this just so that we can see it a little bit better on our side and have that work explained to you a little bit better. Alright, we set up our problem this time for the equivalent ratios, and let's talk about what we have going on here. First off, on the left hand side, on the right hand side, you can see where they're comparing the number of minutes to the difference in heartbeats. And remember, they got that 160 by subtracting the dog from the cat. Next, we set up our goal, comparing our goal of 6 minutes to, once again, the difference in the heartbeats. For here, we're going to do kind of a unit rate, but it's going to be an upside down unit rate because of how they set it up. I'm going to take, and where I've got the 4 over 160, I'm going to divide that top and bottom by 4. And when I do, now I will see that 1 minute is going to equal to 40 heartbeats. And we're going to call that HBs. Now we're going to take that 1 over 40, and we're going to multiply it times the target of 6 minutes, which will be 6 over 6. And we can see that now you've got 6 minutes is going to equal to 6 times 40, that is 240 heartbeats. The same answer that they came up with the other way. Now if you scroll through your slides, it's going to end up looking very similar to that. They took and multiply by this magic 1.5 to get to 6. I don't really like that because they don't really say where that 1.5 came from. I really like my approach a little bit better. And then they did the same thing to the 160 to get to the 240, but that's kind of voodoo math there because they're not justifying that. Either way you go though, you're going to be putting in 240 for an answer right here. Check it. All is good. For their think about it, it says a classmate stated you can also find the unit rate in heartbeats per minute first, and then multiply each unit rate by 6 to determine the number of heartbeats in 6 minutes for each animal, and finally subtract out the difference. Is this method valid? Well, it's very similar to what I did, because I did find the unit rate. Granted, it's upside down, but I did find the unit rate 40 heartbeats in 1 minute, and then I multiply that by the 6 over 6 to find the same 240 that we looked at earlier. They're saying to do that for each individual animal and then find the difference. That would work too, but it would be a fair piece more work that you'd have to, keep up with. Moving on to resource number 6. This problem is the same general idea where we're going to use either or both a double number line and equivalent rates to solve the rate problems. We're going to solve the same problem two different ways. First, a bulk food store sells a 12-pound bag of Red Delicious apples for $18. At this rate, what is the price of a 15-pound bag of apples? Before you think about it, will the price of 15-pound of apples be less than twice as much as a 12-pound bag? Why or why not? Well, twice the 12-pound bag would be 24 pounds. And if we're dealing with equivalent ratios, that would mean that we'd be doing twice the price as well. But we don't need 24 pounds of apples. We only need 15. So it would indeed be less than twice as much. Method 1 is going to use your double number line. Once again, we're going to move through the slides, and you can see they set it up originally with a 18 to 12 ratio. The $18 for 12 apples. And they broke it down into 4 sections. 1, 2, 3, 4, with the mystery 15 fifth section out beyond that. 4 was a good thing to break it down into because it allowed us to divide it into parts of 3 for the pounds, and we would only need to add 3 pounds to the 12 to get it to equal to the 15. From there, they took and divided the top part, 18 by 4, and that gave them 4.5. And then they did the same thing, adding that 4.5 each step along the way, and they found out that they'd have $9 for 6 pounds, $13.50 for 9 pounds, and our target goal, $22.50 for the 15-pound bag of apples. That's a perfectly good way to solve this. I'm not a huge fan of the double number line because I just don't like working them. They're not fun to me. I would much rather use the equivalent rates, which is what we're going to do next. For this one, we're going to do the same basic thing. You can see they have set it up, and we're going to do a screenshot and look at how they solved it. Alright, let's take a look at what we did here. To do the equivalent ratios, you can see they have got everything set up here to where on the right hand side they've got the 12 pounds of apples for $18. On the left hand side they got your 15 pounds of apples for some unknown price. And we've got to come up with something in order to figure out how to do this. Now, I got a sneaky suspicion your textbook is going to use multiplication because that's what they have been using all along, and that is exactly what they did here. They multiplied 12 by 1.25, but where on earth did that 1.25 come from? I mean, they just pulled that out of the air. They saw the number floating by and said, whoop, yeah, let's grab that and we'll see if we can use it. No, they didn't. Let me show you where that came from. They said what that 15 divided by 12, 12 goes into 15 one times, which is 12. That is going to end up leaving 3 left over. Annexing your decimal and your 0. Your decimal goes up, your 0 goes down. 12 goes into 30 2 times, and then 2 times 12 is 24. That's going to leave 6 left over. Annex in another 0 and bring it down. And how many times does 12 go into 6? 5 times. That's the reason they said that 12 times 1.25 is equal to 15. Likewise, you could say that 18 times 1.25 is going to give us our final answer, and when you multiply that out, you're going to get the same $22.50 that they got last time. So let's go back to our textbook. We'll take and plug in our answer that we came up with of 22.5, and 22.50 because it's money. Hit our check button, and everything checks. It looks good. Moving on to our next slide. The average weight of a Red Delicious apple is going to be about 5 ounces. How many apples would it expect to be in a 15-pound bag? Well, just a ballpark, I'm going to say, well, how many ounces are in a pound? 16. So, how many apples are in a pound? 3. And then from there, 3 times 15 is going to give you what? 45, and 45 will be the answer to that problem. Moving forward. Alright, that check did not work, so we skipped it, and now it is your time. You get to pick. Do you want to use the double number line, or do you want to use equivalent rates to find out how many calories there's going to be in 7 scoops of ice cream? Stop the recording and work on this one. Now, as I've said before, I like using equivalent rates better, so that was what I did. I set up my proportion comparing 810 to 3 on the left is equal to some unknown calories to 7 on the right. Now, if we were to use multiplication like they've been doing before, you would actually be multiplying 3 times 2.33333 repeating to get to equal to 7. Or you could do it as a fraction as 2 1/3. Instead of doing that, I noticed that 810, well, that's 81, and 81 is divisible by 3. That becomes 27. So 810 divided by 3 is going to be 270. So I'm going to use my favorite unit rate approach. Take 810 divided by 3, and that's going to give me 270 over 1. Now I can take that 270 over 1 and multiply that times the goal of 7. If I do it on the bottom, I have to do it on the top. And now I can see that 7 scoops of ice cream is going to equal to 7 times 0 is 0. 7 times 7 is 49. 7 times 2 is 14. Plus the 4 is going to be 18. So the magic answer is going to be 1,490 calories for 7 scoops of ice cream. Moral to that story, don't eat 7 scoops of ice cream. Now we're going to take and go back to our answer, 1,490. We're going to check it, and uh-oh, what did I do wrong? I did some bad carrying of my numbers here. I didn't do that, set it up right. I did the 14 and forgot to carry the 4 from my 8. So that should be 1,890, which is even worse. Definitely don't want to eat those 7 things of ice cream. So we're going to try again. We're going to change that number to be 8. We're going to check our answer, and voila, we got it right. Moving on to our next resource. Kashia can ride her bike 15 miles in 90 minutes. She wants to ride a bike-a-thon that consists of 2 open trail options and a 56-mile trail or a 56-mile trail or a 36-mile trail. At a current rate of speed, how many more hours will it take her to ride the 56 miles than the 36 miles? If she chooses to ride for about 4 hours, which trail should she choose? So we've got 2 questions here. Question number 1 says, at her current rate, how many more hours will it take her to ride 56 than 36? And question number 2 says, which trail should she choose if she wants to ride for 4 hours? So with that in mind, we're going to go ahead and press our next button. And that one isn't even going to give it to us. Now they want us to actually solve this. So you pause your recording, solve it, and let's see what I end up getting. And we'll compare answers. Looking at the first part of this problem, I think that what I'm going to do, breaking it down, I believe we have a talk about it section here maybe. Do they have the talk about it? Oh yeah. What task are we going to do? After that, how would you approach the task? After that, what is your solution? And finally, how can you show this is reasonable? You pause the recording and do all these parts, and then we will come back and talk about it. So how will I approach this? First, I'm going to find out how long it takes her to ride 1 mile. Next, I will find the difference in the total miles and multiply that by the 1 mile time to answer the first question. Finally, I will multiply the 1 mile time by both the 56 and 36 mile routes to find out which one of those is going to be closest to the 4 hours. So here we go. This one's going to take quite a bit of work, so let's get it knocked out. First, I know that we can go 90 minutes for 15 miles. That means if I divide it by 15 over 15, shouldn't be doing that funky shape thing, over 15, that would mean that 1 mile would take me, so let's see here, I believe that would be 6 minutes. 6 times 15 is 90, yep, so 1 mile is going to be 6 minutes. And I'm going to circle that, not because it's the answer, but it is an important sub-answer. Next, I'm going to find out the difference of my miles. So I'm going to take the 56 miles minus the 36 miles, and that's going to give me a difference of 20 miles. And I'm going to multiply that by the 6 over 1. So where I have the 6 over 1, I'm going to multiply by 20 over 20, and that is going to end up equaling 6 times 20 is going to end up being 120 over 20 minutes. So the 20 mile difference is going to be 120 minutes difference, also known as 2 hours difference. So for this part here, the answer to at the current rate, it will take how many hours longer. We were working in minutes, now we're working in hours, because 120 minutes is equal to 2 hours, right? So we've got that part done. Finally, we need to find out which route is going to be closest to a 4-hour route. Now, I'm thinking it's going to be 36 minutes. So that's the one I'm going to do. I'm going to take the 6 over 1, multiply it by 36 over 36, and that way I'm going to find out that the 36 mile route is going to take, well, 6 times 6 is 36, 6 times 3 is going to be 18, plus the 6 from that is going to be 226 minutes. If you were to break that down, there is, in your hours, you've got 60 minutes is 1 hour, 120 minutes is 2 hours, 180 minutes is 3 hours. So if 240 minutes is going to equal to 4 hours, that's going to be pretty close. Let's find out what we would get if we did the 56 mile route. So 6 over 1 times 56 over 56, that's going to end up equaling, well, let's see here. Of course, we're going to have 56 on the bottom. And on the top, 6 times 6 is 36. 6 times 5 is 30, plus the 6 from before, that's 36. And that is actually, boys and girls, going to be equal to 6 hours and 6 minutes. So which one of these routes should she choose if she wants to be closer to a 4-hour time? I am definitely thinking the answer is going to be that one right there. So with that, I'm going to go back up here and say that she should choose a 36 mile trail. We're going to check our answers, and it's good. And then you can take and write in something here about how you would choose to defend your solution. Our talk about it says, if Kashia raises $1.50 for each mile she rides, how much more money would she raise if she chose the 56 mile trail instead of the 36 mile trail? Explain your answer. So, well, we could take and multiply $1.50 times 56 and $1.50 times 36 and then find out what we have there. But if you take a look, let's get my pen back over here. If you take a look right back over here, we already have a difference between them. There's 20 miles difference, so all we have to do is take and multiply. Let's go ahead and get ourselves a little working room here. $1.50 times the 20 mile difference. 0 times 0, 0. 0 times 5, 0. 0 times 1, 0. 2 times 0, 0. 2 times 5 is 10. 2 times 1 is 2. Plus the 1 from the 5 is going to be 3. Or from the 10 is going to be 3. Then we're going to go bounce, bounce. Add those up. Bounce, bounce. So the difference she would make is going to be $30. Our check did not work, so now we have one extra apply left to do. You pause the recording, solve this one, submit your answers, and check them. So Brecken, where do they come up with these names? Brecken drove from his house to his sister's house 195 miles away in 3 hours. That looks like it's going to be a ratio there, so I'm going to take and write 193 miles, and let's make my pen a little bit bigger for y'all, over 3 hours. Then he drove to his sister's house, from his sister's house to his parents' house, 315 miles away, and this one took him 5 hours. How much faster was the faster route? Now this is a prime example of a great place to use some unit rates. So I'm going to start off on the top and divide the top and bottom by 3 to find out how long it would take to do, or how fast you could travel in 1 hour. And when we did that, of course 1 hour is going to be on the bottom, 3 goes into, let's go ahead and do our scratch work so you can see where it's all coming from. 3 goes into 19 6 times. 6 times 3 is 18 with 1 left over. Bring down the 5. 3 goes into 15 5 times, which is 15 with nothing left over. So this one is going to be 65 miles per hour. For the other one, we're going to divide by 5 over 5. That's going to give us a unit rate for 1 hour. And when we take and divide 315 by 5, 5 goes into 30 6 times. 6 times 5 is going to be, 31 6 times. 6 times 5 is 30 with 1 left over. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15 with nothing left over. So this one is going to be 63 miles per hour. If you wanted to find out the difference, 65 minus 63, that is going to be a 2 mile per hour difference. And who's the faster trip? The sister is a faster trip. I guess he was more excited about going to see his sister than he was about going to see his family. So sister's house is a whopping, what did we come up with here? 2 miles per hour difference. 2. Check our answer. Everything is good. And that is it for this lesson. Y'all work hard on your homework. Make sure you are giving me quality supporting work to justify every answer you give me. You can't just throw down answers, boys and girls. You got to give me supporting work to justify it. I look forward to seeing what you turn in.